my name is Div Harish, and I'm very excited to tell you about our iLoadPro digital USB load cells. Okay, so this sensor is about 3¼ inches in diameter, and we have versions of this that go up to 10,000 pounds of capacity. So you can see it has a raised boss with a threaded hole, so you can actually attach something to it here, and it comes out with this mini B connector from which you can get UART or serial TTL output, and then by putting on this dongle we convert that into a USB output. Okay, so now this sensor has, it is approved for CE, FCC, UL markings, and as you can see it has 3 mounting holes at the base, and those are threaded holes. So it has mounting on the top as well as on the bottom. So this is our iLoadPro load cell. Now if you want to do compression force measurements, there is a hole here, so in order to plug the hole we have what we call the load button, LB1220 or LB325, and you can just screw it into it. So now it plugs the hole and you can actually apply a force on top of it. So that's the LB325. So again we have the iLoadPro load cell. If you want to do tensile force measurements, or if you want to attach it instead of using these 3 threaded mounts, if you want a single mounting feature on the back of it, you can take this load cell like this and attach our tension adapter. And you can see now we have a sensor that looks symmetrical, the mounting hole on the top as well as a single mounting hole on the bottom. So you can attach something to it from the bottom and attach something to it from the top. Okay, so now we have this load cell with the tension adapter. We can take rod ends. These rod ends are basically like an eye bolt. This is an eye bolt, but this is a rod end. The difference between the two is it's got a swiveling bearing here. So this sort of helps you to level the load in the axis, along the axis of the load cell. So you can attach this like this and attach this at the bottom, and so now you have a load cell with threaded rods on both ends, and you can either pull on it using this thing or push on it, and because of the swiveling it lets you avoid side loads. So again we have our load cell here. If you wanted to build a very quick scale, let's say to put some kind of a little container on top, you can take this, we call it a foot, a leveling foot. So you can just screw this in to the top of the load cell, and now it becomes a little scale if you want. If you turn it around, you can put 4 of these on the 4 corners of a platform and it becomes a platform scale. So you don't have to have this tension adapter, you can do without the tension adapter, but you'll have a foot, and that would be the quickest way. Use 4 of these load cells and then a USB hub, and then go to the PC and you would have a complete scale with 4 sensors at 4 corners. In this configuration you don't have to have the tension adapter, you can just do it without a tension adapter. You can just use the available 3 mounting holes. So 1, 2, 3, and you can bring a frame and put a frame, put this under the frame to make the scale. So this is a leveling foot which is firm. It's got a little rubberized shock absorber built into it to avoid noise from the floor and stuff like that. But if you wanted a leveling foot, where this could swivel a little bit, you can use this guy instead. So in the sensor you don't have to have this. Instead you can use this fellow, and that way even if the surface of the ground is not perfectly flat, this is a little bit forgiving, so it can adjust itself to make the scale be horizontal and flat, and axially apply the load into the load cell. Take this load cell with the USB output and plug it directly into the USB port of your PC. It makes a little sound to show that the PC has detected the sensor. So let's launch SensorVUE here. When it first starts up, it goes and looks for all available sensors. Here it found one. We tear it and then click Start to see it. You can also log the data, so you can give it a file name and say OK. And you can select how often you want it to be logged. And then you can also do a graph of force versus time. So as you can see here, we're applying some force, and you can see the force is going up and coming down and so on. You can see the values as well as log the data and plot the data. So although this is a digital load cell, and as you can see it can be connected to the USB port, using our HX100 breakout board, we uncouple this from the dongle and we connect it in here, and then we go with the output and go back into the USB. So the USB port provides the power, but using these two pins here, you can get a voltage output as well. So it's optional. We don't do it routinely for all the load cells, but for some people who want digital and analog, you can access the analog output this way, and you can go into your DAC or PLC while at the same time looking at the digital values coming from the load cell on your PC. Hi, my name is Div Harish, and thank you for watching this video and demonstration. Please give us a call and we'll be very happy to work with you. Thank you very much.